Muhammad Hafiz Diandra bin Sabudi. My ID number is 2023644998.
Hi, my name is Muhammad Akil bin Yusran and my student's ID is 2023 85 3198.
Hi, my name is Mama Afid bin Hashim. My student ID is 2023677718.
Hi guys,
Hi.
Hi.
do you all have any idea for the video that Dr. Falila has assigned us to do?
I think I have one idea in my mind that we can use for our group assignment about the application of geometry in our daily life. My idea is we can use Honeycomb as our first application. How about both of you?
I think I have some idea in my mind, which is battery and pyramid.
I agree with both of you, but we only need 2 applications. So how about we choose honeycomb and battery, since there are already a lot of people choose pyramid before. Are you guys agree?
Yes.
Yes.
Okay, so we agree with this.
Assalamualaikum and hi everyone. In this video, we are going to present about the application of geometry in our daily life. Our group chose about honeycomb and battery as our group assignment. In honeycomb, the application involves the shape and type of pattern used. Here, a video about honeycomb before we continue on our main topic. So let's go. First of all, we look at history of honeycomb. In 1718, Swiss naturalist named Francois Huber revolutionized beehive design by introducing movable comb. Huber designed his hive as an aid to study the history of bee. His hive would go on to inspire the Langstroth design that is a staple in beekeeping best practice. Honeycomb is comprised of hollow, thin walled hexagon about 5.5 mm wide and 7 mm deep, made from wax secreted from gland on the worker bee abdomens. The ensuing cell of which using the side of the flanking cell in their contraction. Comb cells are attached to the hive frame and it creates a vertical all to the rise new bees and store pollen and honey.
Okay, so what the uses of honeycomb? Honeycomb can be used as a nursery for new bees, placed to store pollen where it can turn into bee blood, and as a storage for the hive's honey reserve. In the wild, bee colonies place brood cells in the center, with pollen combs around them, and honeycomb in outer layer of cells. In man-made hive, brood comb is placed in the lower frames followed by the pollen combs.
From this topic, we will calculate 3 things. These are perimeter, total surface area and volume of the honeycomb. As we said earlier, honeycomb has side length of 5.5 mm and 11 mm of height. Based on the diagram, we will calculate the perimeter by adding all of its sides, or we can simplify the calculation by finding perimeter of its both base and add with the seed height of the hexagonal prism of the honeycomb. So for the perimeter, we can do 2 times 5.5 times 6, which is the base, plus 6 times 11 equal to 66 plus 66. And the last final answer is 132 mm for perimeter. we will calculate the surface area. To calculate surface area, we need to separate all of the shape contained in the hexagonal prism, which are hexagon and rectangle, to make it easy for calculation. First, we will calculate the surface area for the hexagon. Based on the diagram, we will be using 1/2AP as its formula because we don't have the radius to calculate it by using the other formula. To find the surface area of hexagon, we need to find the value of apothem first. To do so, we need to get both of its angle as the diagram shows. X equal to 360 over 6 divided by 2 equal to 30 degree. Meanwhile, y is equal to 180 times 6 minus 2 over 6 divided by 2, and the answer is 60 degree. Next, to find the apothem, we need to use the sine rule, which is a over sine a equal to b over sine b. A over sine 60 degree is equal to 2.75 over sine 30 degree. Then we need to so we can simplify it by moving the sine 60 degree to the right. Then A will equal to 4.763 millimeter. After we got the value of apothem, we need to find the area of hexagon by substitute the value of A and the value of B. Then after we substitute both of the value, we will get the area of hexagon equal to 78.5895 millimeter square. Then we will find the area of rectangle. The area of a rectangle equal to 5.5 times 11, and the answer is 60.5 millimeter square. The total surface area is equal to total area of hexagon plus the total area of rectangle, which is 2 times 78.6895 plus 6 times 60.5. The final answer is 520.179 millimeter square. Lastly, to calculate the volume of hexagonal prism, we use the formula, which is base area times height. For the base area, we already calculated it before, and we get 78.5895. So we just need to substitute it into the formula. So the final answer we get 864.58545 millimeter cube.
Next, we will continue on our second topic. The second topic that we choose for geometry application in daily life is about battery. The application involved in this topic is the shape used in it. Before we move further into the topic, let's watch some video about battery. Now, we will move into our main topic about battery. First, what is a battery? Battery is an essential device that stores chemical energy that is converted to electricity. Basically, batteries are small chemical reactors with a reaction producing energetic electrons ready to flow through external device. Next, we will move into history of battery. American scientist and inventor Benjamin Franklin first used the term battery in 1749 when he was doing experiment with electricity. The first true battery was invented by Italian physicist Alessandro Volta in 1800. He stacked discs of copper and zinc separated by cloth soaked in salty water. Wires connect to either end of the stack produce a continuous stable current. Today, batteries come in a range of size from large megawatt size, which store power from solar farms or substation to guarantee stable supply in entire village or island, down to tiny batteries like those used in electronic watch.
Okay, so for our first calculation, we will calculate the surface area of the battery. So, before we calculate the surface area, we must divide the battery into two parts, whereby there is large cylinder and small cylinder that was on the top of the battery. So first, we will calculate the surface area of the large cylinder. So based on the information that is given, height of the large cylinder is 15.5 mm and diameter is 14.5 mm. So to find the area of a cylinder, we must have a radius, whereby we will divide the diameter by 2 and we will get 7.25. Okay, so to calculate the surface area of the large cylinder, we can use the formula of cylinder with two bases, which is 2 pi rh plus pi r square plus pi capital R square minus pi r square, whereby pi r square is the area of the bottom base and pi capital R square minus pi r square is area of the upper base. So we will put 15.5 mm into H and 7.25 in R, and we will put 2.75 in R in at the upper base. So we will get the answer, which is 2606.9329 millimeter square for the surface area of the large cylinder. Okay, so next we will calculate the surface area of the small cylinder. For this, we will use the formula of cylinder with one base, which is 2 pi rh plus pi r square. So we will put the head of the small cylinder, which is 1 mm in H, and 2.75 as the R of the small cylinder, and we will get the answer, which is 41.0371 millimeter square. So to get the total of the surface area, we will combine the surface area of the large cylinder and surface area of the small cylinder, whereby we will get the final answer, which is 2647.97 millimeter square.
Okay, to calculate the total volume of battery, we should find the volume large cylinder and volume small cylinder. For volume large cylinder, we use the formula pi r square h. So for radius large cylinder, we get 7.25, and the height we get 5.5. So we substitute into the formula, we get 8,339.0632 millimeter square. For the volume small cylinder, we use the same formula, which is pi r square h. For radius, for the small cylinder, we get 2.75, and the height for the small cylinders we get 1. So we substitute it, we get 23.7585 millimeter square. The total volume, we need to add the both volume and get the answer is 8362.8215 millimeter cube.
In conclusion, geometry has an impact on us in even the smallest aspect of our life. Geometry are used in variety of fields, including art, measurement, and building. Furthermore, geometry provides many foundational skills and contribute to the growth of logical thinking, deductive reasoning, analytical reasoning, and problem-solving abilities.